Okay, this is the prerequisite review for section 2.3. In this worksheet, we will be solving quadratic equations using the square root property. We will actually be solving quadratic equations by factoring. We will solve linear inequalities and absolute value equations, and also find the x and y intercepts of a graph. So let's begin with solving quadratic equations by using the square root property. So we want to isolate the square first. And then we will take the square root of both sides. So here we will add 7 to both sides. And as you can see, we will end up with k squared equals a positive 7. Now we will take the square root of both sides, but when we take the square root of this side, let me erase that and move that over a little bit. We must put a plus or minus in front of it, any even root. So now we have k equals plus or minus the square root of 7. Okay, let's do that again. So we need to isolate the squared term, so we will add 4 to both sides. And we end up with 6p squared equals 72. Now before we go on, we still want to isolate the square term, so we will divide both sides by 6, and we will have p squared equals 12. And again, we're going to take the square root of both sides, plus or minus the square root of this side. And so we will have, let me rewrite that. We will have p equals plus or minus the square root of 12. Now, let's talk about the square root of 12, because we can actually see that 12 is 4 times 3, and that 4, the square root of 4 is 2. So that 4 can come out as a 2, and the 3 remains. So p equals plus or minus 2 root 3. Okay, let's go ahead and take a look here. Again, we have to isolate the square term first. So we will go ahead and subtract 4, and we will have 11 equals, let me switch that color. We will have 11 equals 3w squared. We will divide both sides by 3, and we have 11 thirds equals w squared. Now, what we need to do now is go ahead and rewrite. Let's just turn this around. I think that will be better. So now let's go ahead and find, see if I can move that over just a bit. Okay, so remember, we have w equals plus or minus the square root of 11 thirds. But we will need to rationalize that denominator. That actually says plus or minus the square root of 11 over the square root of 3. And we can't leave that square root of 3 in the denominator. So we will multiply the numerator and denominator by the square root of 3. And now we have w equals plus or minus the square root of 33 over 3. So keep in mind, when we multiply across, right? And then the square root of 3 times the square root of 3 is 3. Okay. Okay, Now, let's go ahead and take a look at these quadratic equations. It says by any method, but if you notice, we have a squared term and a first term. We have a squared term and the variable to the first, a square and the variable to the first. All of these mean that we will have to factor into two binomials, okay? We will come up with two binomials, each one of these. So first, we need to set the equation equal to 0. So all terms have to be on one side of the equation. So let's go ahead and see that we're ready to go with this one. I will come down here and I will actually go ahead and multiply A times C, which is a negative 70. And then we have a negative 9 for B, and two numbers that multiply together to get a 70. You might be thinking about a 10 and a 7, but you're not going to get a 9 from that. So just starting to think about some different numbers. You could go ahead and take a calculator and you can, play with the numbers. But if you see that 70 is 14 times 5, you will want to go ahead and write those down, a 14 and a 5. And adding those up, you'll want that negative to be the 14. So negative 14 times 5 is a negative 70. Negative 14 plus a 5 is a negative 9. So we definitely have those correct. We will go ahead and divide both of these by 7k, and we can reduce this one to a negative 2 over k. And this one, of course, is ready to go. So we can see now that we have a k minus 2 multiplied by a 7k plus 5. And that's where we came up with those. So to solve this, either k minus 2 is equal to 0 or 7k plus 5 is equal to 0. And we have k equal to 2. And we have k equal to negative 5/7. Now, what do you notice the difference here? Before we begin, we do have to move that 24 over. So we have 2m squared plus 13m minus 24 equals 0. So we go ahead and make our work on our factoring, and we have a negative 48 and we have a positive 13. So you can go ahead and take a look at a few numbers. You can probably see that we have a 16 and a 3, and 16 minus 3 is 13, and 16 multiplied by negative 3 is a negative 48. So we will go ahead and divide both of those by 2m, and we are good to go there, and this is 8 over m. And so now we have m plus 8 multiplied by 2m minus 3. So either m plus 8 equals 0 or 2m minus 3 equals 0. And you can see that m equals negative 8 or m equals 3/2. So we do have two solutions there. Okay, looks like we're ready to go. We have our equation set equal to 0 here. So we have a negative 30 and a positive 7. So you can say a 15 and a 2, but you're probably thinking about a 10 and a 3. So 10 minus 3 is 7, and 10 multiplied by a negative 3 is negative 30. So we will go ahead and divide both of those by 10x. And of course, we have to simplify this bottom one, this one on the left, and we end up with x plus 1 multiplied by 10x minus 3. So either x plus 1 equals 0 or 10x minus 3 equals 0. And we have an x equals -1 or x equals 3/10. Okay. Now let's talk about some inequalities, some linear inequalities. So here we have a less than or equal, and we will be writing in interval notation, our solutions in interval notation. So we're going to work these the same way. I'm going to add 4 to both sides, and I have a negative 2x is less than or equal to 15. And now I'm going to divide both sides by a -2. And of course, when we divide by a negative, we are going to have to reverse that sign. So we will have a -15/2. Oops. And we end up with an x. So x is greater than -15/2. Let's go to a number line. And we have greater than or equal. And we want everything larger. So we have -15/2 to infinity as our solution. Okay, let's go ahead and take a look at this next one. We will subtract 6n from both sides, and we have a -2n plus 2 is less than 8. We will subtract 2. We have a -2n is less than 6. And again, dividing by a negative, we are going to have to reverse that sign, and we end up with n is greater than -3. Let's go ahead and make a number line. Here's a -3. We have an open circle, and I meant to say n is greater than -3 because we reversed the sign. So there we have -3 all the way to infinity as our solution. Let me write this one just a little bit larger. So that was a -15/2 to positive infinity. Okay, now we are going to talk about absolute value equations. And keep in mind that the absolute value of a positive number is that number. The absolute value of a negative number is that number that now is positive. And I always like to throw this in. The absolute value of 0 is just 0. Okay, so we always want to isolate the absolute value term first. So here we will subtract 5 from both sides, and we will have the absolute value of x is equal to 6. And we will actually write x is equal to 6, and then we will write the opposite of 6. So our answer will be -6 and a +6. Okay. Let's go ahead and try that again. This is already isolated, the absolute value. So we will say 3x plus 7 is equal to 10, or 3x plus 7 is equal to a -10. So now we will subtract 7. I like to work both of them at the same time, but you can do them one by one. 3x equals 3, and dividing both sides by 3, we have x is equal to 1. And then we also can have 3x is equal to a -17. And we have, divide both sides by 3. And we have x is equal to a -17/3. And I'll see if I can move this up just a touch. and maybe a little bit smaller like the other side. And then we have two different ways, okay? So we always will take plus or minus the other side. Here we go. We have 2x minus 4 is equal to 5, taking those absolute values off. 2x minus 4 could be equal to negative 5. Either way. So we will add 4. And we have 2x equals 9. Dividing both sides by 2. We have x is equal to 9/2. And you know, I could have written this solution set over here like that if we wanted. Okay. Okay. So now let's continue on. And we have 2x equals a negative 1. And dividing both sides by 2, we have x equal to negative 1/2. So our solution set here is 9/2, negative 1/2. Okay? Looking at number 12, I don't know where that came from. We first need to isolate that absolute value. So we will have to go ahead and write this as the absolute value of 2y plus 1 is equal to 6. And now we will have our two equations. 2y plus 1 equals 6, or 2y plus 1 equals a negative 6. So subtracting 1, we have a 2y equals 5 and a 2y equals negative 7. And dividing both sides by 2, you can see I like to work them side by side. We have y equals 5/2, or y equals negative 7/2. Okay. Finally, we will end this section with finding the x and y intercepts. So when we look for an x-intercept, we let y be 0. When we're trying to find a y-intercept, we let x be 0. So let's go ahead and start here in part A. If we're going to find the x-intercept, we're going to let y equal 0. So let's do that. 4x plus 5 times 0 equals 0. 5 times 0 is 0. 4x equals 0. Dividing both sides by 4, you have x is equal to 0. So x equal to 0 is our x-intercept. Now, you could go ahead and say that when x is 0, y is 0. Okay? So now let's go ahead and find our y-intercept. And here we're letting x be 0, and you're going to see something. We already said that when x is 0, y is 0. But let's just go ahead and work it out. So we have 4 times 0 plus 5y equals 0. 5y equals 0. And y is equal to 0. Same point. So both the x and the y-intercepts are 0. Let's do the same thing over here in number 14. In here, we're going to go ahead and first find the x-intercept, and we're going to let y be 0. So we have 3x plus 6 times 0 equals 12. So we have 3x equal to 12. and we come up with x equal to 4. Now, x equal to 4 is the x-intercept, and the point that's generated is 4, 0. That is where the graph hits the x-axis, okay? But intercepts truly are numbers, but you might see them given as an ordered pair. Now we're looking for our y-intercept, and here we will let x be 0. So now we have 3 times 0 plus 6y equals 12. 6y equals 12. And we come up with y is equal to 2. So we have 0, 2 is our point. When x is 0, y is 2. And that concludes this section.